All right, Chapter 4, Section 4, Part 4. We are still factoring, but now we're going to be factoring perfect squares. So perfect squares are numbers like 1, 2, 1, 4, 9, 16. And these are perfect squares because 1 is 1 times 1. 4 is 2 times 2. 9 is 3 times 3. 16 is 4 times 4. What's 5 times 5? So 25 is another perfect square. What's 6 times 6? 36. What about 7 times 7? 49. 8 times 8? 64. And 9 times 9? 81. So these are perfect squares. We'll see these show up a lot in this section. So it's important to note these perfect squares. I would write it down if you don't know them already. So if we're given a perfect square trinomial, we can use this shortcut because our answer is going to be a perfect square binomial like this. So it's going to be some binomial that repeats itself, so we can just put that little squared there. But this only works if our equation is given to us in this form. If this is a perfect square and this is a perfect square. So what times what gives us x squared? X times x. And what times what gives us 25? 5 times 5. And then the middle has to be in the form of 2 times the first one and the second one, x times 5. So that's 10x. So it's perfect. So because it meets all of these rules, we can use our shortcut and put x plus 5 squared. So when you have a perfect square trinomial, your answer is going to be this perfect square binomial. If you wanted to, you can factor this the normal way, which I'll rewrite it here for you guys so you can see. So I have x squared plus 10x plus 25. What are two factors of 25 that add to 10? 5 and 5. So my parentheses here would be x plus 5, x plus 5. Since we're multiplying these, we can just say x plus 5 squared. So this way is just a shortcut when you have perfect squares. All right, let's go to the next example. So is 36x squared a perfect square? What times what gives us 36? And what times what gives us x squared? X. And then is 4 a perfect square? What times what gives us 4? 2 times 2. And then in the middle, do I get 2 times the first one, which is 6x, times 2? So I wrote the example wrong. Let's pretend that this is a 24. So yes, it works. So we can use our shortcut. What would go into my parentheses here? Awesome, 6x plus 2. So we just write this one and put it in the parentheses. And it's squared. So because we're using our perfect square shortcut, we have to make it squared. So for this one, if we wanted to do it the long way, we would have 36x squared plus 24x plus 4. I would have to multiply the first times the last. So 36 times 4 is 144. Two factors of 144 that add to 24, 12 and 12. So then in my parentheses, I would have x plus 12, x plus 12. But I have to divide them by 36. Yeah, it would be 1/3, which would be x plus 3, x plus 3. so it doesn't work for this one. Let's do the next example. So these are the same, but the formula looks a little bit different just because we have a minus in the middle. So that means in our parentheses down here, we're going to have a minus in the middle. So that changes just that one part, but everything else stays the same. So 4x squared is a perfect square. Tara, what times what gives us 4? 2. So this would be 2x. And Tara, what times what gives us 36? 6. So I just put the 2 and the 6 in here. So 2x minus 6, and then we square. We don't do anything with that. It's just to check to make sure that we can use the shortcut. So it would be 2 times 2x times 6. Because it's always 2 times the first one times the third one. And that would give us 24. So it's just to check. All right, let's take a look at the next one. So, is 64 a perfect square?
Yes.
Yeah, what times what gives us 64? 8 times 8. And then x times x gives us x squared, so it has to be 8x. Is 1 a perfect square? Yeah, what times what gives us 1? 1. So in my parentheses, I'm going to put 8x and 1. And what's going to go in the middle? A minus, because I have a minus here. And then this is squared.
So you just bring down the minus?
Yep.
If it's a plus?
If it's a plus, then it'll be a plus in the middle. All right, so next we have the difference of 2 squares. So it's just going to be giving us 2 terms. And we can factor it when it's only 2 terms if they are perfect squares. So we do that by rewriting it. So what times what gives us 25? 5. And then we need that x for the x squared. And what times what gives us 49? 7. So when it gives me 2 terms, I need 2 sets of parentheses. And then I just write 5x plus 7 and 5x minus 7. So when you use the difference of 2 squares, so when it has 2 terms, you need 2 parentheses. 2, yeah, so we have a perfect square here and a perfect square here. We can factor it, but we need like the 2 different parentheses. And the reason why we can't make this like 5x plus 7 squared is because this one's a plus 7 and that one's a minus 7. So they're different, so we have to rewrite it. Any questions here? With different signs in the middle, yeah. All right, example 3. Is 16x squared a perfect square? Yeah, what times what gives us 16? 4 times 4. So we have 4x. Is 81 a perfect square? What times what gives us 81? 9. So what goes into my parentheses? Awesome, 4x minus 9 and 4x plus 9. It doesn't matter the order. You could say this or 4x plus 9, 4x minus 9. The order doesn't matter. So just know when you have 2 terms, your answer is going to have 2 parentheses.